Welcome to my third video in the Time Value Money series, Teaching Notes for the Spiceland 7th edition, Chapter 6. In this topic, our topic today will be the present value of a single amount. Let's start with an interesting topic. On page 4 of these notes, I made a future value interest factor of how $1 would grow for 10% for 4 years. And I grew it by 10%, as you can see, and it ended up growing to be 1.4641. We all remember that. It was lovely. Well, if you were to chart this, and only roughly, because it was really hard to make this chart, that $1 would, over 4 years, grow on a 10% growth curve. And that's what a future value chart does. It takes you out using table 1. Well, you can come back the other direction. $1.46 received 4 years from that would be how much today kind of concept. Whereas table 1 grows you by 10%. Table 2 discounts you back to the present by whatever percent you're looking at, in this case 10%. Table 2 is the reciprocal of table 1, which reciprocal meaning 1 divided by the number from table 1 would equal the number on table 2. So table 1 just shows you a 10% growth curve. Going out, table 2 brings you back. When I say a reciprocal, just dividing by 1 divided by, I mean it literally. Take a look at the formula for table 1, and then take a look at the formula for table 2. Table 2 is 1 divided by table 1. In my first column, I've presented for you the interest factors from n equals 4, I equals 10% from table 1. Year 1, year 2, year 3, and year 4. To make the reciprocal of these for table 2, you should just be able to take 1 divided by these numbers. 1 divided by 1.10 is 0.9090. 1 divided by 1.21 is 0.82644. Put it on pause, please, and finish the next 2 rows. How'd you do? You made the reciprocal of table 1, which created table 2. Focus for a second on the 4th year. The 4th year at 10%, 0.68301. Go to table 2. Here's the screenshot. 10%, 4 years, 0.68301. Some poor fool had to grow $1 by 10% to make table 1, and then probably that same poor fool had to come back and make the reciprocal of it so you could come back on that growth curve. Just like I brought you a little excerpt from table 2, there are many rows that you can see, and the numbers do agree. So if you want to move out on that growth curve, use table 1. The future value equals the present value times an interest factor with an n and an I. And if you want to come back on that curve, take the present value and times its future value with the present value factor where n and I, and it will work for you. So, let's ask a simple question. How much is $1.46 worth today if you have to wait 4 years to receive it? Notice I put the question mark here, signaling to me I'm looking for a present value, not a future value. It was a future value, it was over here. Now I'm looking for the present value. Using the tables, you can say the present value is equal to the future value times an interest factor where n equals 4 and I equals 1. Well, the future value was $1.4641 times that factor on our table. We just did the reciprocal of 0.6830, and it brings you back to $1. This would lead you to the same accumulation or amortization schedule that we had before. It starts at $1, it ends at $1.46. Both of these prove table 1 In table 2, this is where it starts, the present value, and this is where it ends, the future value. Well, given that it works that way with $1, it would work that way with any amount of dollars. How much is an investment that's worth $7,320 at the end of 4 years worth today if you could invest it at 10%? I think you already know that. We did it, but let's use the formula. Take the future value, 7320, and realize we're looking for the present value, so go to the present value table. N equals 4, I equals 10%, interest factor 0.6830, times it out, and you got it. It equals $5,000. Table 1 and 2 always end up with the same fund accumulation schedule. In one table, they show you where it starts, and in the bottom line of the same table, they tell you where it ends. This is going backwards. This is going forwards. Well, if you're really good at this, then you've understood all of that. Let me give you an arbitrary question that you can solve. If you need $10,000 to buy your kid a car in 4 years, how much do you have to set aside today to accomplish that if you can earn 12%? Well, we know that we can use a table for that, so let's use our formula. What is the present value? That's where my question mark is. Let's take the future value of 10,000 and times it by an interest factor from table 2, the present value table, where n equals 4, and this time I equals 12. Look up that interest factor right now, and you'll see table 2, it's 0.6355. Take 10,000 and times it by 0.6355, and it gives you 63.55. Work because I did 10,000. So the present value is 63.55, and the future value is 10,000. Please put this on pause and finish that table for me. Welcome back. How'd you do? Hope you remembered to times by 0.12 instead of 0.10, because I used 12% in my example. 63.55, our starting point, times 12%, 71.18. End of the period, start the next period, the next date, that amount, grow it by 12%, 79.72. Start the next period with that, grow it by 12%, 89.29. Start the period with that, leave it invested, earn 1,071, and ends at 10,000. The fund accumulation schedule proved that our table 2 worked. So you should review pages 323 and 330 in this book, and you'll find that table 1 and table 2, in summary, the charts were built using $1, so they can work for any amounts of dollars. You can plug in any dollar amount you want, and that interest factor will work because it was done on $1. Table 2 is a reciprocal of table 1. And in order for those tables to work, it requires a constant rate of interest and equal periods of time. We use 12% without changing. We use periods of a year without changing. These are things that the tables require. Now review pages 323 to 330 and see if all of that makes sense. Thanks for joining me on this third video where I was looking for the present value of a single amount. Added a little theory, and there you go. Thanks for joining me. Talk to you soon now. Bye.